everyone, and welcome to this module on DevOps fundamentals. And in this module, we will be discussing on what exactly DevOps is, what are the prerequisites to learn DevOps, and then we'll be talking about the software development life cycle. We'll be talking about a use case where we'll be looking at the Instagram Reels feature that was rolled out back in 2020. And then we'll be talking about the doc launching technique, what exactly it is and how it is implemented by the usage of DevOps. And then we'll be looking at different components of complete DevOps so that you can have a complete understanding what exactly is included in DevOps and what exactly you have to learn in order to be called as a successful DevOps engineer. Now, first thing first, there is a prerequisites to everything. So whenever you're, for example, you're going to learn the web development, or whether you are going for any kind of visualization expertise, you're going for machine learning, you are going to learn, let's say, the cloud. So there has to be a prerequisite for everything, as in what exactly you need to understand before you can get into the module. So there are no specific or can say some hard level prerequisites for DevOps, but we do have a basic prerequisites here, that is Linux. And Linux is something which is now common to every single thing that you are going to learn, whether you are going to go for dev or development or analysis or cloud. So Linux knowledge is required because majority of all the solutions that we work on, they all are built on top of Linux-based operating systems. So we may have been familiar working with, let's say, Windows or Mac OS. Mac OS itself is built on Linux. So we need to know how the entire file system works in Linux, how we can work with common commands, like we have to create directory, how to copy those directories, how to work with the file level permissions, how to make use of the library managers available in Linux. So these all common skill set is needed for getting into DevOps. And these are something that are already going to be covered. So even though you are completely new into this domain, you are not much familiar with Linux, how that works. So you will be learning those things once you start learning DevOps, because this is going to be the first module itself. And once you're familiar with the Linux common operations, then we'll be moving on to the core DevOps knowledge. So DevOps is something which is adopted by every application, by every company. It doesn't matter what scale they are currently working on, be it the entry-level companies or the big-level enterprises. They all have been using DevOps for deploying and maintaining the application on cloud. So anyone who is interested in DevOps, for example, let's say you are a fresh graduate and you know that again DevOps is being used by multiple companies, but you don't know exactly what DevOps is, what exactly goes into DevOps, how the application is deployed and developed by using its methodologies. So this is going to be a good fit for you. Developers who are expert in getting the application design and pushed to the production team for testing, but they are now also keen to understand how they can implement the DevOps lifecycle into their development process. For example, you may be familiar with Agile, you may be familiar with the Scrum methodologies for development, but now you also need to know DevOps for moving on to the next scale. So this is going to be a good fit for you. All these systems administrators and engineers, because in DevOps, everyone works together. We have developers, the QA testers, the automation engineers, the system operations team, the monitoring team, they all work together. So we, as a system admin or these operations manager, we have to know how we can maintain the entire infrastructure, how we can ensure whatever has been submitted by developers, they are pushed and maintained on the right environment, how the metrics they are going to be monitored. So that is why it is also good for any system operations engineer. Then we have for networking administrators, at the end, the entire infra is going to be part of a network. If the network is itself down, then the entire operations cannot work. So being the one who is working in network administrator or engineering domain, it will be good for us to have the expertise of DevOps so that we can know, okay, these are the restrictions that are applied. This is how the entire network flow works from one component to the other, what all firewalls and security aspects have to be defined while we are pushing the application from one stage to another. And then we have all the quality assurance engineers, because whatever applications are going to be created, they need to be pushed for testing as well. Because let's say we have designed the application, but because of negligence or because because of any human error, the form validation is not done. For example, the form is not working as expected. The submit button is not working as expected. The data for the apps was required to be pushed from the databases. Data is not being displayed correctly. So we need to have the thorough testing done for each and every functionality that we are going to push as a part of DevOps lifecycle. And this is going to be the job of QA engineers. And then all the operations engineers, they have to be familiar, okay, how exactly they can work with maintaining the entire health status in terms of making sure that the least amount of resources are going to be needed by the application that they are going to deploy and maintain. So these are all things which are responsibility for DevOps engineers. And that's why if we are going to work in any of these specific areas, we should be learning DevOps. Now, in terms of the software development, we need to have the good, we can say, model available. So when you talk about the traditional waterfall model, so it is the conventional model that we used to follow when we designed applications almost 2 decades back. It is still in use for simple applications, which does not require much editing. For example, if we are going to create a simple informational website that once done, it may be updated, let's say in next 6 months or 1 year or 2 years, and there is not much update, there's no changes needed in that kind of application. So that's where waterfall is going to be a good fit for that. And then here we have the agile development, which is going to be suited when there are going to be frequent changes done to the application and the development needs to be fast. For example, when we are going to create any application here, the main focus is always around client happiness. So we can break the application into smaller parts. We can have those smaller components created, and then we can have them deployed all at once. So the individual component deployment is not going to be possible under Agile. And DevOps simply solve that. So we can even break the application to smaller parts and have those smaller components pushed and made available to the end user, from where the feedback of those components can be recorded and it can be sent back to developers to either retain them and make it available to the larger audience, or if any change is needed, then those changes can be applied and then it can be republished to the said environment. So again, a feedback can be recorded and can be sent back to developers as a continuous process. So that is what we have in terms of DevOps. Now, talking about a small use case. So Instagram has been one of the applications which has changed a lot in last 1 decade, especially after its acquisition by Facebook. So there have been continuous features being added here. So earlier we used to have a simple photo specific application where we could simply share photos, that's it. Then the feature of chat was added. Then we could see who exactly liked our photos or who we are, or okay, what kind of photos we have liked. And then there were features for adding the videos as well. There was feature added to send a message so that we can communicate to each other by using text. There was a feature added to have something called as Reels added here. So Reels was same or similar to having a short video format, and Instagram Reels was introduced back in 2020, and it allowed the content creators to create short video format and have it posted, because it's all about having the content served in the quickest time possible. No one is having time to sit down and watch, let's say, an hour or 2 long videos unless that is a good movie or a good TV show. So that's why Reel has been the most popular format of content being, we can say, consumed in last couple of years. And that is why even the long format YouTube videos, they are not that much viewed as compared to Reels. So the entire world is on Reels right now. So this was developed, and whenever any application at this scale tries to deploy any application new feature, for example, that new feature can be as simple as rolling out a new like button. So that like button may be liked by the audience or it may be hated. So we cannot, for example, if the application is having a 1 million user base on a per month basis, so the application is never going to roll out that feature to entire 1 billion user base. It is simply going to select a small audience. It is going to roll out that feature to the small audience, gather the feedback, how they perceive that, if they are liking it or not, and if there is a positive response, then it can be tested on a larger audience. And then when it has been approved by a good percentage of audience, let's say maximum number of audience, then it can be rolled out as a main feature, or can say an update to the main application altogether. So these all things are being done by using a process called as the dark mode launch. So this brings us to the next topic, which is we have in terms of dark launching technique. So according to dark launching technique, all the features are going to be introduced to a smaller user base, because if a feature is not going to be liked by masses, then we don't want to upset our main user base. Again, if a small user base is upset, then that's okay, we can ignore that. But let's say if 70 to 80 or 90% of the user base gets upset with one specific feature or application, then that is not going to be a good user experience that we want for our end users to have. So as we discussed, a small feature is going to be created, and then it is going to be tested on a very small user base, and if they like it, then it will be tested against a larger user base. If they like it, then it will be tested again on a much larger user base, and so on, until and unless majority of our user base approves that, and they are continuously monitored, and the feedbacks are developed, and again there are multiple iterations created from those specific features, and then those are also going to be released on the platform, so it can be accessed by the same user base. And once the features are stable, there are no bugs, they have been well approved, they are liked by the audience, then they will be deployed to multiple other user bases in future, or we can say future releases. So for example, let's say the new feature is always going to have the option of on and off, which is going to be sent to the stakeholders, first of all, for their approval. Once they approve that, then they'll be rolled out to the specific set of users, and then they may report bugs. For example, Instagram Reels may have a bug reported that again, whenever the user is going to try to move on to next reel, then it simply stops working. Then that can be a bug which can be sent back to the developer team, so that again a new feature can be created or it can be fixed, and then that fix is again going to be sent to the same user base to see if that is working fine. If that is approved, then it is going to be rolled out to the other user bases, and then their feedback is gathered, and so on. So that's why in this entire process, the continuous development, testing, integration, deployment, monitoring, so they all are being defined. So we make sure again we do follow the continuous development, testing, and integration methodologies, because without having a continuity in each and every process, this launch method cannot work, because we cannot simply launch a feature and simply stop. It has to be a continuous process, making a release, making iterations, having it released, collecting the feedback, again making changes, having it released, again collecting feedback, and so on. And that is why even the symbol of DevOps is an infinite symbol. That means it is going to be up and running on a continuous basis. So if you talk about DevOps, then DevOps is basically a principle that we follow when we are going to create any application. And there are 8 core components available in DevOps, starting with plan, then we have the code. So DevOps, as we know, is basically a continuous process which involves these 8 main lifecycle methods, which always starts with the planning. In planning, we ensure that we do get whatever we need in designing the application. We have a complete understanding of what kind of technologies, platforms are needed, what exactly is the timeline of the launch, how it is going to be planned in different phases, how many team members are going to work on it, who is going to work on which specific component of the application. That means entire planning is going to be done. Then we move on to the coding phase, where we focus on getting the application built and making sure that all the versions of the applications are saved. Then we move on to the building phase, because again, once the application has been coded, we have to create a deployable build out of it by using multiple build platforms. Then we have to make sure that we do test those specific application components by using multiple testing scripts. And then once everything is going to be done here, then we have to package them all together into a single package entity. And that is what we define as a part of a continuous integration tool. Once we package them all together, and that too in an automated manner, then we have it deployed on a containerized platform, and then we take care of the configuration changes if any is needed, and then we simply keep on monitoring and keep sending the feedback of the same to the developers, so that they can create a new iteration of the product, and then they can have it released back. So in terms of the platform, as you can see here in the planning stage, first of all, we make use of platforms like we have Jira or we have Trello. We have other tools also available, like we have Planio, or it can be any other custom, we can say, planning tool that we can make use of. So these tools allow us to have the entire project broken down into smaller parts. For example, here we can create something called as a sprint. In sprint, we can define whatever tasks have to be completed in terms of a backlog, and then those can be assigned to a specific user with a given timeline. And if the project is not completed, we can say that component is not completed within a given timeline, then there'll be penalties, there are multiple accountabilities generated. So that is all maintained by having a planning tool, because without planning, our entire application cannot be created and it cannot be maintained in a smooth manner. That is why it is of utmost importance. Then under the coding stage, now we can build the application in any language, be it Python, be it JavaScript or Node.js, or it can be Go application, it can be built on Ruby, any language. But again, whatever we are going to make use of, we have to ensure that we do keep on tracking the changes done in these applications. For example, if we have done 10 changes in the core application file built on Python, and now we want to go back to any of the previous code, then that is where having a version control system is important. And that is where tools that we have the Git as a main version tool, or we can make use of SVN as a single distributor, or as a single version controls tool, or centralized, it is going to be important. So Git is the most popular version control tool where we can use it for tracking changes on code, which is going to be built in any language. And as a part of the IDE as an integrated development environment, we can make use of VS Code, or you can make use of Eclipse or IntelliJ, whatever type of application that we are trying to create. It can be PyCharm if we have a Python specific application in place. And then in terms of the build platform, here we make use of tools that we have Gradle, we have Maven, Apache Ant. So building is important, because once the code has been created, in order for that code to be sent, or we can say shared, to the operations team in the staging environment or production environment, we have to package the application as a part of a complete build, so that all the application files can be built as a single build file. Like in Java, we have a jar file. So we may have, I suppose, hundreds of files in our application, but it won't be feasible for us to share those 100 files along with whatever dependencies they have. So instead of sharing that, what we do is we simply package them all together in a single file, and then we share this file with the operations team, so that once they execute this build file, they will be able to see the application the way it was structured. And that is why we can use tools that we have Maven, we have Apache and Gradle. They are most popular build tool available. So using build, we can have the code compiled, reviewed, and packaged into a deployable file that can be easily shared across. And here we can do that by using a script. For example, in Maven, we can simply define a script, and here in this script, we define how the application has to be built, and this script is going to have the build defined for us automatically. So if we are going to pull the code from a given repository, like we may have, or let's say a code available in other repository-based setup, then we can easily have it pulled and we can have it built all together. Then here we do have the testing platform. So basically we have tools that we have Selenium, JUnit, we have Appium, QUnit, we have Postman. So basically whatever applications we are going to create, we have to create a thorough testing script. So testing can be of two different types. It can be a manual testing, where a manual tester is going to sit with the application and do multiple testing and then generate a report, or we can have it automated by using the automated testing method, where we can create a testing script where we can define what exactly we need to test as a part of the application component, and that testing script is going to perform the test based on whatever parameters we have defined, and it is going to generate a report of the test for us automatically. So this is what we do by using these testing platforms. So once the build of the code is available to us, then we can have this testing script attached to the build, so that it can go ahead and work with the build that we have created and run the test, and then give us the result or pass those results back to the developers so that they can work on it accordingly. Then we have the deployment platform, or we can say deployment stage. Now, before deployment, we have integration. So these all things can be done manually, or we can have the entire code pulled from these different services, or we can say platforms. For example, once the developers they are done building the code, they can move the code to a remote repository, like we have GitHub. And then we want to ensure that again there should be a platform that can pull the code directly from the repository and have the build done in case build needs to be done, or any kind of testing script that needs to be attached, that can be attached, and then it can be automatically sent to the deployment platform. So that kind of automation is what is done by using integration, and that is where tools like we have Jenkins, they are useful. Like we have Jenkins, Hudson, we have Bamboo. They are the most popular platforms for continuous integration in terms of pulling the code, having having the build created, and then attaching a testing script on top of it. And then we have the deployment. So once the code is available, or we can say ready to be deployed, it has to be deployed on a platform. And that is where tools that we have Docker and Kubernetes comes into the picture. So Docker is going to be used for creating a containerized version of the application. So containerized means the application along with all the bins and libraries needed to run the application, they are all packaged inside a single image container environment so that there is no dependency outside this environment whatsoever. And then this is something that can be used to create a working container, just like a VM. And then we can have multiple containers created. And then if we are having a multiple container setup for any application, then for managing those containers, we use tools like we have Kubernetes, where if you want, we can even scale up the resources as and when needed. And then we can ensure that if any of the container or any of the resources goes down, it can even have the same thing deployed again and again. So for complete management of a cluster of containers, that's where we will be using tools that we have Kubernetes. And then we also need to make sure that whenever any change is required, for example, let's say later on we want to change the configuration of the server, we need to update the PHP servers, we need to install, let's say, MySQL database, we need to modify the keys being used here. So for these different kind of changes, we have to ensure we make use of configuration management tools. Like we have Ansible, we have Chef, Puppet. So these tools are going to be used for making sure that we do have the ability to make modifications to any code we want by using a template. So here we can create a script. We can define on which server we want to install, remove, or update whatever we want. And then this tool is going to automatically do that on a cluster of servers, whether we have one instance in that cluster or whether we have hundreds. And then for monitoring the entire resources, we need to have a service called as Grafana, Nagios, Prometheus being used, because without monitoring the resources in terms of the actual CPU consumption, the memory usage, the logs that they are generating, without monitoring the resource will be working all in dark. If something goes wrong, then we will never be able to know what exactly is wrong and how exactly we are going to rectify that. So these are all going to be part of DevOps. And this is what the complete life cycle of DevOps look like. And since it is going to be done on a continuous manner, that's why the symbol of DevOps is also an infinity symbol. So it is going to stop only if the application has been killed or it has been completely changed. So thank you for watching this module, everyone. See you all in our next module where we are going to talk more about DevOps and its each component in detail.